All right, so this is the next lesson in geometry. The lesson is called Triangle Congruence Theorems, and there's 5 of them that we're going to talk about today. Okay. So previously, in the last lesson, we learned that if 2 triangles have 3 pairs of congruent corresponding angles and 3 pairs of congruent corresponding sides, then the 2 triangles are congruent. Okay. So you have to know 6 things to prove the triangles are congruent. But now we're going to do some shortcuts, okay? However, you do not need to know that all 6 corresponding parts are congruent in order to conclude that the 2 triangles are congruent. For example, it is enough to know that only the corresponding sides are congruent. So that is our first shortcut. It's called side, 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 SSS for short, okay? If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent, okay? So you don't have to know anything about the angles for this problem. As long as you know that 3 sides of one triangle are congruent to 3 sides of another triangle, then you can say the 2 triangles are congruent. Okay? That's the first shortcut, side, 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 or SSS for short. Okay? Now let's look at the second shortcut. The second shortcut is called side angle side, SAS. If 2 sides and the included angle of one triangle, so I'm going to talk about that in the next page, but the included angle is the angle in between 2 sides, okay? So for example, if I'm talking about side AB and side AC, and I say, what is the included angle? That means what angle is in between those 2 sides? It would be angle A. Okay, so if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. Okay, it has to be the included angle. It has to go side, included angle, side. Side, included angle, side. If you know that, then you can conclude that the 2 triangles are congruent. That's side, angle, side. Okay? So let's talk about that a little bit more. Okay, so just to talk about the included angle more. And included angle is an angle formed by 2 adjacent sides of a polygon. So I mean 2 sides right next to each other. So, for example, angle B is the included angle for AB and BC. That's just one example. If I'm talking about sides AB and sides BC, and I say, what is the included angle? It would be angle B, because that's the angle in between them. Similarly, an included side is the common side of 2 consecutive angles in a polygon. We're focusing on triangles mainly, but this is true for any polygon. An included side is the common side of 2 consecutive angles in a polygon. And that's going to be coming up in the next theorem. But for example, PQ is the included side for angle P and angle Q. Okay? So if I say, what is the included side of angle P and angle Q, that means what side is in between them, and it would be side PQ, for example. Okay, so those two definitions, we have included angle and we have included side. That leads to our third shortcut. It's called angle side angle, or ASA for short. You know, I'm gonna keep a list of these off to the side. I can refer back to it later in the video. So these are our shortcuts. I'll say triangle congruent shortcuts. I'm just going to keep a list of them so I can refer back to it later in the video. Okay. So first shortcut I gave you is called side, side, side. Then we did side, angle, side. And now we're doing angle, side, angle. So this one is angle, side, angle. If two angles in the included side, this is the included side for these two angles. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. So it has to be the included side. Has to be the included side. So angle, included side, angle, angle, included side, angle. That's enough to prove that the two triangles are congruent. And here's our next shortcut. It's called angle, angle, side. So let's add that to our list. Angle, angle, side. If two angles in a non-included side, so we have two angles in a non-included side of one triangle, are congruent to two angles in a non-included side of another triangle, then the triangles are congruent. So angle, angle, side is the non-included side. The one before this, angle, side, angle, was the included side. And now we have one more shortcut. Before we get to that, there's a few definitions. In a right triangle, so let's assume this is a right triangle. The side opposite the right angle is the longest side, and it has a name. It's called the hypotenuse. So in this diagram, this would be the hypotenuse. The other two sides are called legs. So this would be a leg, and that would be a leg. That leads to our final shortcut. It's called hypotenuse leg, or HL for short. So let me add that to our list. Okay? These are the 5 triangle congruent shortcuts that you have to know. Those are the only 5 that work. No other shortcuts work. We can talk about that maybe in class when I see you. But those are the 5 shortcuts that work. Let's keep that off to the side. I might refer back to that later. Here's the last shortcut, hypotenuse leg, HL for short. If the hypotenuse and a leg of a right triangle, so again, this is only for right triangles, can you use this? Only for right triangles. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent, okay? So again, that's only for right triangles can you use hypotenuse leg. Sure. Example 1. Determine whether you have enough information to prove the two triangles are congruent. If you do, state the postulate or the theorem that can be used to prove the triangle is congruent, and write a congruent statement. Okay, so example 1A. You have this side congruent to that side, and you have this side congruent to that side. Now, this side, AC, is in common in both. That's not going to be labeled for you, but you can label that yourself. Reflexive property. This side is in common in both triangles, so I would just put 1 tick mark on there if I were you. And if you do that, you see that the two triangles are congruent by one of our 5 shortcuts from earlier today. It's side, side, side. Look, side, 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 side. So the two triangles are congruent by side, side, side. Here's how you have to write your answer. You have to write a congruent statement. So for example, I'm going to say triangle ABC is congruent to triangle. You have to go in the same order. So what that means is if I say A, B, C, I'm going in this order. I'm going the 2 tick mark side, then the 3 tick mark side, A, B, C. 2 tick marks, then 3. I have to go in the same order when I list the bottom triangle. I got to go 2 tick marks, then 3. So I'm going to say it's congruent to triangle CDA by side, side, side. Okay? So this side in common of both is not going to be labeled. You have to label that yourself. Example 1B. You have this angle congruent to that angle. Okay. This side is congruent to that side. That's great. Now, you also have vertical angles, and you know that they're congruent, so you have to label that yourself. Those will not be labeled for you. You have to label the vertical angles being congruent by yourself. And if you do that, you'll see we have one of our shortcuts from the beginning of the lesson. It goes angle, included side, angle. Angle, included side, angle. So they're congruent by angle, side, angle. So I'm going to say triangle EFI. So I'm doing the angle with 1 arc, 2 arcs, then no arcs. I have to go in the same order for the next one. So I'm going to say it's congruent to triangle GFH by angle, side, angle. Okay? Angle, side, angle, angle, side, angle. It's the included side. Example 1C. You have the right angles labeled, so that might give you a little hint for what the answer is. Okay? Right triangles don't always have to be HL, but usually they are. So this side in the middle is in common to both. Let's label that ourselves. And now you'll see it's going to be hypotenuse leg because we have the right angles, and therefore we have the right triangles. You have the hypotenuse congruent to itself, and you have the legs congruent. So I'm going to say triangle JLM. You should go in the same order for the next one. JLM is congruent to triangle JLK by HL. The next one, we're going to have to label the vertical angles ourselves. So let's label that vertical angle being congruent to that vertical angle. All vertical angles are congruent, vertical angle theorem. And now you'll see it goes side, included angle, side. Side, included angle, side. So the 2 triangles are congruent by side, angle, side. So I'll say triangle QNR. I go in the same order, so I'm doing 1 tick mark, then 2. I have to say it's congruent to triangle PNO, 1 tick mark, then 2. By side, included angle, side. Example 1E, we can label the vertical angles being congruent, but this triangle goes side, angle, side. This one does not go side, angle, side because it's not the included angle. This one goes angle, side, side. This one goes side, angle, side. So it's the included angle up here. It's not the included angle down there. So I'm going to say not enough information. We don't know if these are congruent. So I'll say not enough information. It doesn't match any of our 5 shortcuts. I'll say not enough information to conclude that the 2 triangles are congruent. In the last one, we have this side in common to both. Now let's see if we have any of our shortcuts. And we do. Angle, angle, side. Angle, angle, side. So it's not the included side. It goes angle, angle, side. So I'm going to say triangle XYA.
Good afternoon. Please pardon the interruption. If there are any ninth grade students who have yet to come down to the spine to receive their new Chromebooks, please send them down now. Thank you very much and have a great day.
I'll say triangle XYA, one arc, two arcs, no arcs, is congruent to triangle ZAY, one arc, two arcs, no arcs. And that's by angle, angle, side. Okay, last problem, example 2. State what additional information is required in order to know that the triangles are congruent for the given reason. Okay, example 1, 2A. What else do you need for side, side, side? Okay, you do not need to be told that QS is congruent to QS. You should know that yourself. Label that yourself. You do not need to be told that. You should know that yourself. So what else do you need for side, side, side? Is you need to know that RQ is congruent to BQ. That's what you need. You need that. That's what you need. Okay. For the next example, what else do you need for hypotenuse leg? You have the right angles being congruent. Okay, that's good. You know that they're right angles, and you know that they're right triangles. You know that this leg is congruent to that leg. What you need is the hypotenuses to be congruent. So you need to know that IJ is congruent to ZY. That's what you need. One second. All right, here we go, part C. What else do you need for angle, angle, side? Okay, so you already know that this angle right there is congruent to that angle right there because of the vertical angle theorem. You do not need to be told that, okay? So first let me tell you what the wrong answer is. The wrong answer would be saying you need angle K congruent to angle W, because if you had that, it would go angle included side angle, angle included side angle. So that's not the right answer, okay? What you need is angle U congruent to angle I, because if you had that, then it does go angle, angle, side, angle, angle, side. So that's what you need. You need angle U to be congruent to angle I. If you had that, then you would have angle, angle, side. This next one, what do you need for side, angle, side? Well, you already have this side congruent to itself. You should know that. You do not need to be told that. You need side, angle, side, so you need this angle with the star and that angle with the star, because if you have those two angles with the stars, then it goes side, included angle, side, side, included angle, side. And make sure you label that with 3 letters. That way you know what angle you're talking about. If you just say angle K, that's confusing. You need angle JKL to be congruent to angle VKL. That's what you need for side, angle, side. Okay. One second. And this last one, what do you need for angle, side, angle? Now, you already know that the vertical angles are congruent, so label that yourself. You do not need to be told that. You should know that. For angle, side, angle, it means you need the included sides congruent. So it means you need side AB and side BL. So if you have that, then it does go angle, included side, angle. Angle, included side, angle. So you need AB to be congruent to LB. Okay, and that is the end of that lesson. Those are the triangle congruence theorems. Those are the 5 shortcuts that you have to know. Side, 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 angle, 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 side, and hypotenuse leg. Those are the 5 shortcuts to prove 2 triangles are congruent. Memorize those.